Welcome to my YouTube channel. I am Engineer Umar. Today, we're diving into the heart of turbine mechanics, the high-speed coupling system. If you're working with steam turbines, gearboxes, or rotating machinery, this episode is for you. Let's explore how high-speed couplings work, their role between the turbine and gear, how they manage vibrations, and why they are more complex than low-speed couplings. Let's get started. What is a high-speed coupling? Animation of turbine connected to gearbox via coupling. High-speed couplings are mechanical devices that connect the turbine shaft to another rotating component, usually a gearbox or generator shaft, while transmitting torque and accommodating slight misalignments. In turbines, especially those operating at high RPMs like 3000 or 6000 RPM, the precision, balance, and flexibility of the coupling is extremely critical. A failure in this component can lead to catastrophic damage. There are multiple types of high-speed couplings, but the most common ones used in turbines include diaphragm couplings, disc couplings, gear couplings, flexible couplings, shrouded type or laminate. Role of high-speed coupling in turbines. Movie camera turbine spinning, power flowing through coupling to gear. The high-speed coupling serves the following key roles. 1. Torque transmission. It transfers high torque from the turbine rotor to the gearbox or generator with minimal energy loss. 2. Compensation for misalignment. Despite precision alignments, minor misalignments are inevitable due to thermal expansion, foundation settling, or assembly tolerances. High-speed couplings allow for angular, axial, and parallel misalignments. 3. Vibration dampening. It acts as a mechanical buffer, helping to reduce the transmission of vibrations between components. 4. Safety. In the event of an overload or imbalance, the coupling can sometimes act as a sacrificial component, protecting the turbine or gearbox. 5. Ease of maintenance. High-speed couplings are designed for periodic inspection and shim adjustments without needing full turbine disassembly. Flexible shims, what are they and how do they work? Close-up of shims being inserted between coupling flanges. Flexible shims are thin metal sheets inserted between coupling flanges to fine-tune axial spacing and alignment between the turbine and the gearbox. White heavy checkmark functions of flexible shims. 1. Alignment adjustment. They help to precisely adjust the axial and radial position of the coupling halves. 2. Thermal growth compensation. As turbines heat up, the casing and shafts expand. Shims allow technicians to pre-adjust for these expansions. 3. Vibration control. Misalignment is a major cause of rotor vibration. Shims help ensure that the coupling maintains concentric rotation and reduces shaft whipping. 4. Balance restoration. During routine overhauls, if coupling imbalance is observed, shims are added or removed in micro increments to restore balance. Hammer and wrench # common shim materials. Stainless steel, non-corrosive and durable. Bronze or aluminum, in light applications. L4, vibration and the coupling gear interface. Movie camera, visual, shaft with vibration sensor readings. Vibration is one of the most critical challenges in high-speed machinery. At the turbine gear interface, vibration can arise due to shaft misalignment, uneven torque transmission, imbalance in coupling or rotors, bearing wear or soft foundation. The high-speed coupling plays a critical role in reducing this vibration through 1. Flexible elements. Disc or diaphragm couplings can flex slightly, absorbing vibrational energy before it reaches the gearbox. 2. Torsional damping. Gear-type couplings can provide damping of torsional vibrations, which helps in smooth torque transmission. 3. Vibration isolation. Couplings reduce the transmission of high-frequency vibrations from one shaft to another, protecting sensitive bearings. Part 5. How high-speed coupling differs from low-speed coupling. Movie camera, visual, split screen showing both types. High-speed and low-speed couplings serve similar purposes but are structurally and functionally different. Aspect: high-speed coupling, low-speed coupling. Operating speed 3000 to 10,000 RPM, 100 to 1500 RPM. Design tolerance very tight, more lenient. Balancing requirement: high precision dynamic balance, static or basic balance. Misalignment flexibility: moderate to low high. Thermal compensation required, less critical. Cost and complexity: expensive, complex, cheaper, simpler. Material strength: high grade alloys, standard steel or cast iron. Microphone hash: so, while low speed couplings are designed more for flexibility and durability, high speed couplings focus on precision, balance, and vibration suppression. Part 6: Coupling installation, key considerations. Movie camera, visual. Maintenance crew installing coupling. Installing a high-speed coupling in a turbine setup demands accuracy and care. Here are critical points to remember. 1. Laser alignment. Laser-based shaft alignment tools are used to ensure precise alignment before installing the coupling. 2. Proper shim thickness. Shims should be selected based on thermal calculations and cold alignment requirements. 3. Torque tightening. All bolts in the coupling should be torqued uniformly using calibrated torque wrenches. 4. Runout checks. Radial and axial runout of the coupling flanges must be within the acceptable limits, often below 0.03 mm. 5. Balancing. Dynamic balancing of the entire rotor coupling gear assembly is necessary for smooth operation. Part 7: Common problems and solutions. Movie camera, visual, list of problems and technicians solving them. 1. Vibration during startup. White have a checkmark: check alignment, rotor balance, and coupling torque values. 2. Abnormal noise or humming. White have a checkmark: investigate for shim misplacement or coupling element wear. 3. Excessive temperature near coupling. White have a checkmark: check for friction due to tight clearances or lack of lubrication in gear couplings. 4. Coupling tooth wear in gear type. White have a checkmark: ensure proper lubrication and axial movement clearance. Part 8: Case study, turbine to gearbox coupling alignment. Movie camera, visual, site footage or animation of a real-world turbine gearbox setup. In one real-world installation, a 12 MW steam turbine was connected to a reduction gearbox using a flexible diaphragm coupling. During cold alignment, 0.5 mm axial shims were used on the gearbox side. Upon heating, thermal expansion was calculated to be 0.45 mm, and vibration readings remained below 2.5 mm per second RMS, well within ISO standards. This shows how proper use of high-speed coupling, accurate shimming, and cold-hot alignment planning can ensure smooth operation. 9. Inspection and maintenance of high-speed couplings. Movie camera, visual, maintenance checklist animation. Routine inspection is vital. Key tasks include: visual inspection for cracks, corrosion, bolt torque checks, shim condition check, balancing condition with vibration analyzer, lubrication status in gear couplings, end float measurement, high-speed runout measurement during overhaul. 1 o'clock inspection frequency, every 6,000 to 12,000 running hours or as per OEM recommendations. Conclusion: why high-speed couplings matter. Microphone hash: to sum it up, high-speed couplings are not just mechanical connectors. They are precision instruments that protect, stabilize, and enhance the performance of the entire turbine drive system. From vibration damping to thermal adjustment with flexible shims, these couplings play a silent but powerful role in power generation and mechanical efficiency.